Hello, this lesson is geometric sequences, and the whole process of working with geometric sequences is very much like working with arithmetic sequences. It's just that the formulas are a little bit different. When you have a geometric sequence, then with your list of numbers, you multiply to get from one number to the next instead of adding like you do with arithmetic. So if this is our sequence, you can see hopefully that to get from one number to the next, you're multiplying by 2 each time. So what you are commonly multiplying each time to get from one number to the next is called the common ratio. And in our formulas, we'll use the letter R for that. So in this case, R would be 2. Or instead of the numbers getting bigger and bigger, they might be shrinking down. For example, if we had 9, 3, 1/3, not 1/3, but 1, sorry. 1, 1/3, and so on. Then you can see that what's happening to get from one number to the next is that we're dividing by 3. So if you're dividing by 3 each time, what you're really multiplying by is 1/3. And another way to think about, if you can't just look at it and figure out what you're multiplying by every time, you can use the formula of the second term divided by the first term to get R. So in this case, R would be 3 divided by 9, which is 1/3. And you can check a couple more terms and make sure the third divided by the second would be 1/3. The fourth divided by the third would be 1/3. So it should be 1/3 every single time. So if you're not sure what R is, what the common ratio is, if you'll do the second term divided by the first term, that will give it to you. So just like with arithmetic, if we said, what's the fourth or fifth one, that would be pretty easy to get. But if we said, what's the 20th, that would take a lot longer to figure out. So just like with arithmetic, we have a formula to find and here's another formula to mark in your notes, the nth term of a geometric sequence. And the formula is a sub n is equal to a sub 1 times R, that common ratio, to the power of n minus 1. So n minus 1 is an exponent, and we're multiplying instead of adding with that common ratio. So let's try one of these. So that list that we started with, 1, 2, 4, 8. Suppose we want the 20th term. Filling in our formula, we would have a sub 20 is, and our first term is 1, times R, we already figured out, is 2, to the power of n minus 1. N is 20. If we're trying to find the 20th term, n is 20. So 2 to the power of 20 minus 1, which would be 1 times 2 to the 19th, which is 524,288. I want you to be careful when you're working these out. You cannot multiply the number that's sitting out here with the number that's sitting in here that has the exponent on it. You can't multiply that before you handle the exponent. Remember, order of operations, you have to do exponents first. So that's a 1 right there. Let's make sure we know that. So be careful about that. Okay, let's try another one. So again, here's our formula. And we're using our second sequence. Let's find A sub 7, the seventh term. Filling in our formula, then we would have A sub 7 is, and our common ratio, the second divided by the first, remember, gives us 1/3. So our first term is 9 times 1/3 to the power of 7 minus 1. So you cannot multiply the 9 times the 1/3. We have to do 1/3 to the 6th power first, and then multiply by 9. So 1/3 to the 6th power is 1 over 729. You would do 1 to the 6th and 3 to the 6th. And then when you multiply that, you can reduce 9 into 729. If your sequence starts out with fractions, you want to keep fractions, not decimals. So do your reducing, work with your fractions. And so then 1 over 81 would be the seventh term. Again, I forgot, just like with the arithmetic, the nth term of a geometric sequence, this particular formula is called the explicit formula. We'll do a recursive in a minute. Okay, so these instructions say if we are given a term and the common ratio r, we want to find the explicit formula and the first 3 terms. We'll just do 3 instead of 5 for geometric because it's a little bit more complicated. And again, here's our formula. And we are given that our 6th term is 100 and r is equal to 1/2. So filling in the formula for a sub n, we'll put the 100. The first term is what we don't know. R is 1/2, and that's to the power of 6 minus 1. 6 minus 1 is 5. So 1 over 32, 1 to the 5th, 2 to the 5th. Multiply both sides by 32. And a sub 1 is 3200. So then our formula would be a sub n is equal to 3200 times 1/2 to the n minus 1. That's the explicit formula. And then if we want the first 3 terms, we know that the first term is first term is 3200. And then r is what you multiply by each time. So if we multiply by 1/2, the next term is 1600. Multiply by 1/2 again, the third term would be 800. So there's the first 3 terms. Let's try another one. And we are given that a sub 10 is 2400 and that r is 4. Filling into the formula then, we have 2400 is equal to a sub 1 times 4 to the 10 minus 1. So 2400 is a sub 1 times 4 to the ninth. And 4 to the ninth is 262,144. And then divide. Now, a little calculator trick. Let me show you if I can get the calculator up here. So if I'm going to divide both sides by 262,144. So 2400 divided by 262,144. And we have the decimal, but we don't really want the decimal for these sequences. We don't want to round. So we can convert this decimal back to a fraction using the calculator. If you push the math button, which is on the far left column, on the left side, math, and then that very first option means back to fraction. So we hit enter, we choose that first option, hit enter one more time, and it tells us that that's 75 over 8192. So then our formula would be, our explicit formula, a sub n is equal to 75 over 8192 times 4 to the n minus 1. And if we want to give the first three terms, the first one is 75 over 8192. Multiply by 4 each time. The 4 will cancel into the denominator every time. 75 over 2048 and 75 over 512. I'm just multiplying by 4 every time because that's the common ratio. Now the recursive formula. So here's a formula, recursive for a geometric sequence. And the formula is just like with arithmetic, you have to list what the first term is. And then a sub n is equal to r times a sub n minus 1. Remember, a sub n minus 1 refers to the previous term. That's what recursive means, is you have to look back to the previous. So if we want to write a recursive formula for that first list that we had, which was 1, 2, 4, and 8, and we knew that we multiplied by 2 every time, then the formula would be, you list the first term, and then you write a sub n is equal to r, which is 2, times a to the n minus 1. So it's just a plug in, pretty simple. Let's do one more. Okay, again, here's the formula. A sub 1 equals whatever. This is recursive. And we'll do our list that was 9, 3, 1, 1/3. And so r is the second term divided by the first term, which is 1/3. Filling in the formula, a sub 1 is 9, and then a sub n is 1/3 times a sub n minus 1. So that wraps up geometric sequences.